Hello. Okay. Hello, everyone. Right. So, okay. Welcome back. So today is the second webinar on quadratics. So I'm going to go through some more quadratic equations and some quadratic, mostly quadratic equations, and we'll touch quadratic functions if we get a chance. Right. So I've prepared some challenging questions for you today. So some of them will be quite unusual. So a bit different from what we did last 2 weeks ago. I'm going to share my screen, and please let me know that you can see my screen. You can see my screen, type 1. I can see it. Oh, brilliant. Thank you. Okay, so it's the third webinar, and we are off. The first one is, what is the special case for quadratic? It is both year 10 and the year 11. Year 10 and year 11 together, because year 11s do the year 10 program this year. Next year, we will have a separate program for year 11s, but year 11s will be in year 12 by that time, and year 10s will be in year 11. So you'll do the new year 11 program. So the first question, what is the special case for quadratic equation? So this is a trick that I really wanted to show you. And it comes out of Veta's formulae. So it goes like this. So let's say if in a quadratic equation, let's write a quadratic equation. In a quadratic equation, a quadratic equation, ax squared plus bx plus c equals 0. So I hope you won't argue that this is a quadratic equation, by all means. Now, the first special case, if a plus b plus c equals 0, then the first solution is 1, x equals 1, and the second solution is c divided by a. Example. And this is like the first special case. For example, you have x squared, well, let's take 3x squared plus 2x minus 5 equals 0. So you notice that 3 plus 2 minus 5 is 0. 3 plus 2 minus 5 is 0. Ava, can you hear now? Can you hear now? You hear now? No, not Dania. Hear now. Try logging off and back in. I assume other people can hear me. Okay. Okay, good. Now, Dania, you're asking a very good question. How did I get C over A? Well, to answer this question, you will have to do problem number. So let's see, which problem do you need to do? Problem 9. Here, it is actually one of the reasons x1 times x2 equals C over A. Oh yes, and special cases, I have mentioned them. Yes, I have mentioned them in the paper. And yes. I'll just demonstrate. So, okay. So we notice that 3 plus 2 minus 5 is 0. And that means that it's a special case, number 1. That means that the first solution, x1, is 1. And x2 is C over A, which is minus 5 over 3. Minus 5/3. And you would be surprised to learn how many times how often it works. So for example, x squared minus 7x plus 8. That's another example because this is 1. So 1 minus 1 minus 8. That's what I meant this. 1 minus 8 plus 7. 1 minus 8 plus 7 is 0. Therefore, the first solution, x1 equals 1, and x2 is equal to 7, which is quite cool, if you ask me. So that's 7, 8, 8. The second special case, if a minus b plus c equals 0, then the first solution is minus 1, and the second solution is minus c over a. And for example, 5x squared minus 11x plus 6 equals 0. And you can see immediately, you can see immediately that a plus b plus c is not 0, but a minus b plus c is 0. So a minus b plus c is 5 minus 11 plus 6 is 0. Therefore, it is special case number 2, and therefore the first solution is minus 1. The second solution is minus c over a. So it's minus 6 over 5. Minus 6 over 5. And it's brilliant. You'll be surprised to learn how many how often that works, as I said. So I haven't seen any here, but let's look at the previous examples. See this one, this example. So x minus 5 minus 6 is not 0, but x plus, if you change the sign, x plus 5 plus 6 is 0. So the first solution is minus 1. Here it is. And the second solution is minus c over a. So minus 6 over 1. So which is 6. Okay. Where else? Okay, well, this is different. Reaching the square. Right. Well, I'll point it out. I'll point it out if we see it again today. Okay, problem 1. Sorry. Do you understand how the special cases work on a scale of 0 to 10, please? Okay. So in any quadratic equation, and you won't see those quite often. Well, I can't give a proof because then I'll have to prove I'll have to solve problem 9, and you need to solve problem 9. So it comes directly from problem 9, straightforward, straight away. Okay, so problem 1, completing the square. So I've shown you how to complete the square for the first one. You just need to realize, so x squared minus 6x, you need to realize that it's missing a plus 9. Plus 9, but then you have plus 8. So there are 2 ways you can do this. The first way is you can say, well, I have x squared plus 6 plus 8 equals 0. What I do, I need a 9. So what I'm going to do is I'm going to write plus 9 and then minus 9, right? Because that's what we need. And then minus 9 because we've added 9, so we subtract 9. So basically we did nothing. And then we have x squared minus 6x plus 9. So this is a bracket. And then minus 9 plus 8 is minus 1 equals 0. So this is x minus 3 squared equals 1. And that means x minus 3 is equal to plus or minus 1. X is equal to 3 plus or minus 1. The first x1 is 4. x2 is 2. There are 2 solutions, x1 and x2. Or you could say, well, alternatively, you can say x squared plus 6x. We need a 9, right? We need a 9, so we say plus 9. And then, but we have plus 8, so we need to compensate. So we just write minus 1, which makes plus 8. Whichever approach is more comfortable for you, it obviously has the same result. So you can say plus 9 minus 9 plus 8, or you can say plus 9, and what do we need to get 8? Well, minus 1, so 9 minus 1. But in both cases, it's the same thing. X minus 3 squared minus 1 equals 0, and etc., which brings you here. Yes, you can do x squared plus 6x plus 9 equals 1. Yes, absolutely. I understand how to solve this, but I don't know how it works. Is the explanation in the document with the questions on? Well, not exactly, but it is. Let's see. Completing the square. Well, it works like this. Problem 11. Show that the formula can be. Oh no, sorry. You can use the discriminant formula. Actually, if we, yeah, okay. Let me prove this formula because I haven't asked you to prove this formula, I believe. I hope I haven't. I'll double check again. So I'm not asking you to solve problem 10, am I? No, I'm not. So I can safely prove to you the formula. Annotate. Okay. Right, so let's say x squared plus bx plus c is equal to that. Well, it's easier to prove the other way around. Like, let's open this up. So we take x plus b over 2 squared minus b squared over 4 plus c. Open the bracket, so it's x squared plus, we use the formula for the sum, the square of a sum. So it's going to be 2 times x times b over 2. We're using the formula a plus b squared equals a squared plus 2ab plus b squared. So we're doing this here, and that plus b over 2 squared minus b squared over 4 plus c. And then we have x squared plus 2xb over 2 plus b squared over 4 plus c minus b squared over 4 plus c. B squared over 4 and minus b squared over 4 cancel out. 2 cancels out. And we're left with x squared plus xb, which is bx, plus c. So in fact, this is the same as this. Therefore, if you have x squared plus 6x plus 8, that's the one we had before, can be written as x plus b over 2. So x plus 3 over 2. So it's going to be x plus 3 plus 6 over 2. 6 over 2 squared minus b squared, which is 6. So it's 36 over 4 plus c plus 8, which is x plus 3 over 2 minus 9 plus 8, so minus 1. That's exactly what we have. It's the method of having the number. You can use both. You can use both methods. You can use the formula, or you can use a recognition. So here, I use recognition. I recognize that x squared minus 6x is a part of x squared minus 6x plus 9. That's how I did it. And here, I'm just using the formula straightforward. So I'm going to do another one by recognition, and then 2 more by using the formula. So b I'm going to do recognition again. So x squared plus 4x. I recognize that this is part of x squared plus 4x plus 4. Because I've learned these before. I remember that x plus 2 squared is x squared plus 4x plus 4. Then I need to compensate for the added 4, so I do minus 4, and that's it. So I don't do anything else. So I put this into brackets. This is a completed square. There's x plus 2 squared. The 4 goes to the right, so it equals 4. And we have x plus 2 equals plus or minus 2, right? Because if something squared is 4, this something must be plus or minus 2. So x is equal to negative 2 plus or minus 2. So x1 is 0, x2 is negative 4. This is the solution. Now, C and D, so this is B, this is C, and this is D. C and D, I'm going to use the formula. So using the formula C, x squared plus 8x plus 1 equals, now the formula x squared plus bx plus c, I'm just going to write it down, x plus b over 2 squared minus b squared over 4 plus c. And of course, if it's a minus, then it's a minus here. So I'm going to use x plus 8 over 2 squared minus, so 8 squared, so 64 over 4 plus 1. So this is going to be x plus 4 squared minus 16 plus 1, so minus 15. Interesting. Okay, that's fine. And that's equal to 0. So I have x plus 4 is equal to plus or minus, okay, x squared 4 equals 15. There's no square root of 15. There's no integer square root of 15, but there is a square root of 15, plus or minus root 15. So we have x is equal to minus 4 plus or minus root 15. And that means x1 is minus 4 plus root 15. That's how you should leave your answer. And x2 is minus 4 minus root 15. These are the two solutions. Chloe, I'll have a look. I'll have a look at question 7C. I'll see how I can help you just in a second. So question C has a, do you understand how I did it? On a scale of 0 to 10, please, again. Oh, good. So maybe I don't need to go through. Okay. Does anyone, would anyone like me to go through question D? If you would like me to go through question D, say yes, please. Okay, I'm happy to do that. What is the name of the formula? Well, completing the square formula, whatever you want to call it. I'm not too keen on names. Like, yeah. There are sciences which are really focused on giving everything a name. I won't be going through the physics question next week. We do it maths, next week physics. So this is the third webinar. We did maths, then we did physics, now we do maths. Next week it's physics. Right, so here I'm going to use the formula again. So I recognize, I'm going to go through this one a bit slower because obviously if someone wants me to go through, they're not certain. So those of you who understand this very well, try to go and try to solve question 6 and 7. Okay, so those of you who are very confident with question D, go try to do question 7 from here, problem 7, the one I've shown you down here. And I will go through this one a bit slower than the previous one. Okay, so you have this formula for completing the square. And let's make it, let's make it with a minus. Just make it a little bit more interesting with a minus. Okay, so here B is equal to, well, B is equal to 4 and C is equal to 6. And I'm using the formula with a minus. So it's going to be X, open bracket, X minus, because minus, 4 divided by 2. So B divided by 2, 4, close bracket, squared, minus B squared over 4. So B squared is 16. So 16, B squared is 16 over 4 plus C, so plus 6. Therefore, I have equals 0. It still equals 0. So X minus 4 over 2 is 2. So it's going to be X minus 2 squared. 16 over 4 is 4. So minus 4 plus 6. So minus 4 plus 6 equals 0. So X minus 2 squared. And then minus 4 plus 6. So it's going to be plus 2 equals 0. Now, in this is an interesting case, because if you move 2 to the other side, it becomes minus 2. And you have X minus 2 squared equals minus 2. This is impossible. Also, you could say, well, X minus 2 squared plus 2. X minus 2 squared is a positive number. So it's a non-negative number. So it's greater or equal 0. And this is a positive number, greater than 0. If you take two positive numbers, you cannot possibly get 0, which is so not possible, right? There's another reason why it is impossible. Therefore, not possible, not possible. There's a no solutions. No solutions. You could write it in a fancy manner. You can say X belongs to an empty set. There's no, X is an empty set. There are no solutions. Okay. Problem 2. Use discriminant formula to show that Veta is true when A equals 1. So what does that mean? So we're going to problem 2. So those of you who are trying to do question 6 and 7, you can come back. Use discriminant formula. So the discriminant formula, so we have an equation where A equals 1. So that means X squared plus BX plus C equals 0. The discriminant formula is B squared minus 4AC, but A is 1, but 4AC. So it's B squared minus 4C. and x1 is minus b plus square root of b squared minus 4c divided by 2a, but a is 1, so divided by 2. And x2 is minus b minus square root of b squared minus 4c divided by 2. And what do we need to prove? Well, we need to prove Veta's formulae. And Veta's formulae, so we need to prove that x1, x2 is equal to c, and x1 plus x2 is equal to minus b. By the way, please note that these formulas are only true if a equals 0, because if a is not 0, they're slightly different. Sorry, if a is 1, sorry. If a is not 1, the formulas are different. Okay, so well, let's do it straightforward. So we're going to get x1 multiplied by x2. So that's x1, so it's minus b plus square root of b squared minus 4c divided by 2, multiplied by minus b minus square root of b squared minus 4c over 2. Okay, so we need to multiply these two brackets, two fractions. Okay, so 2 times 2 is 4. That's good. Okay, we're happy with that. So minus b, so we're going to multiply it out. So just term by term, this times that, this times that, this times that, this times that. So minus b times minus b is b squared. Minus b times minus, so it's going to be plus b square root b squared minus 4c. Then we have this times that times minus b, so minus b times b squared minus 4c. And then finally this times that. So it's going to be minus, when you multiply two square roots, you get, well, we know that square root of a times square root of a is a. Therefore, square root of b squared minus 4c times b squared minus 4c is b squared minus 4c. Now you can notice that this, the minus this cancels out. Let's open the brackets. We get b squared minus b squared plus 4c divided by 4. This cancels. 4c divided by 4 is equal to c. Yes, I did, yeah. Thank you. So we have, look at that. x1 times x1 is c, just as predicted by Veta's formulae. And now let's do x1 plus x2. This one is easier, actually. So it's minus b plus square root of b squared minus 4c divided by 2 plus minus b plus square root of b squared minus 4c divided by 2. And you can see minus, of course. All right, so minus b. Right, so minus b, so minus 2b. And this thing cancels out. And we have minus 2b over 2, which is minus b. Whoa, x1 plus x2 is minus b, just as predicted. Okay. So question 7c, somebody was asking me about question 7c. Oh, okay. We're going to, as a matter of fact, I have prepared this and this question. They're very similar to question 7c. Like they are disgracefully similar. Okay, so problem 3. Solve and factorize. So this looks like a quadratic equation, except it's not. But we can do something to it to make it quadratic equation. So we notice that let u is equal to x squared. Then u squared is x to the power 4, isn't it? So the equation can be written as 9x to the power 4, which is u squared, plus 23u minus 12 equals 0. Unfortunately, this is not a special case. I'd love it to be a special case, but that's fine. Oh, it doesn't matter. It could be T. It could be zebra. Yeah. So if you doesn't have to be anything. It could be let w equals x squared, then w squared, and then w squared, and then w. Or zebra, then zebra squared, zebra squared, zebra. I just like you, I guess. Okay. And then we can solve this quadratic equation. Okay, so how are we going to do this? Well, we don't, well, use the formula. Why not? So u1 is going to be minus 23 plus or minus square root b squared, so 23 squared, minus 4 multiplied by 9 multiplied by negative 12. Oh, that's going to be a big number. Divided by 18. So minus 23 plus or minus 23 squared, 569. 23 squared, 529 plus 36 times 12, 961. So square root of 961 over 18. Sorry, that's u. That's not u1, that's just u. And we have minus 23 plus or minus, I'm guessing that's 29. 29 divided by 18. Right, so u1 is minus 23 plus 29 divided by 18, which is 6/18, which is a third. And u2, the second solution, u2 is minus 23 minus 29 divided by 18. So minus 23 minus 29, that's 40, 50, 52. Negative 52 over 18, which gives us, divided by 2, that's 26 over 9. That's 26 over 9. Seriously? Am I doing something wrong? 31. Yes, thank you. Sorry. That's embarrassing. 31. Of course it is. 31. I was thinking something embarrassing is going on. So 31. 23, 31. So that makes it 23 minus 31 minus 23. That's 8. That doesn't help. 8 over 18. So that's 4 over 9. Oh, okay, 4 over 9. It makes perfect sense. And then minus 23 minus 31, that's 54. Minus 54 over 18. Oh, and that is 3, I believe. Okay, 54 over 18. 3. Minus 3. Okay. We found u. We haven't found x, though. So we have two options. So u is 4/3, but remember that u is x squared. But u is x squared. Therefore, you have x squared equals 4 over 9, or x squared equals -3. And if x squared equals 4 over 9, that means x is equal to plus or minus 2/3. And x squared equals -3, that's not possible. So x belongs to an empty set because there are no solutions. Therefore, the answer is x1 is 2/3 and x2 is -2/3. That's it. How well do you understand problem 3? On a scale of 0 to 10, please. And Chloe, does it clarify your question? And with the next question, we just dive deeper into complexity. So we have the same thing. And whoa, what about that? We notice. So let u equal 2x minus 1 squared. Then u squared is equal to 2x minus 1 to the power 4. So the equation becomes u squared minus u minus 12 equals 0. And this can be solved by Veta, using Vietas. You don't have to do Vietas. So u1 multiplied by u2 is minus 12. u1 plus u2 is equal to 1. So you add and it makes 1. You multiply, so it's minus 3 and 4. u1 is minus 3. u2 is 4. Okay, so I've shown, if you missed last week's, if you missed the webinar 2 weeks ago, look it up, please. I was explaining what Veta is and how to use it. No, you just try it, and if it doesn't work, you don't use it, pretty much. You can calculate the discriminant, but then it takes more time than to do Veta. So if the discriminant is a square number, then you can use Veta. If discriminant is not a square number, you can't use Veta. But then the point of Veta is to do it very, very quickly. Dania, no, you don't. You can use Veta when the answers are not whole numbers, and we did that 2 weeks ago. We did Vietas where they weren't whole numbers. Okay, so here, did we? Sorry, I might have. Yeah, we did. Look at this one. So look back at that webinar if you can use Veta with non-whole numbers. So you found u, and that means that 2x minus 1 squared is equal to -3, or 2x minus 1 squared equals 4. Now, this one is not possible. So this is x belongs to an empty set, not possible. And here we have 2x minus 1 is equal to plus or minus 2. So 2x equals 1 plus or minus 2. So x1 is equal to 3 over 2. And x2 is minus 1 minus 2. That's minus 1 over 2. So these are the two answers. Okay. Here it looks very similar to problem 4, but it's not clear. Well, obviously you can say u is x plus 2 squared, and u squared is, so then u squared is x plus 2 to the power 4. So that is u to the power 4. That's yeah, that's true. But what is this? What is this monster? Well, actually, if you think about it, if you take the 2 out, you can complete the square. You need to complete the square here. You need to complete the square. Completing the square. So 2x squared plus 8x minus 16 is equal to 2, open bracket, x squared plus 4x minus 8. And that is 2, x squared plus 4x plus, so what we need, we are missing another 4, then minus 4 minus 8. So that is 2, open bracket, x plus 2 squared minus 12 equals 2, open bracket, x plus 2 squared minus 24. So what we did is we saw this, and we saw that this could be written as this. So let's rewrite it. We notice. So that means that x plus 2 to the power 4 plus 2, open bracket, x plus 2 squared minus 24 equals 0. And what do you notice? You notice that this is u squared plus 2u minus 24 equals 0. We can use the Vetas here. So beautiful numbers, u1, u2 is equal to negative 24. u1 plus u2 is equal to negative 2. So it's going to be negative 6 and 4. So u1 is negative 6, u2 is 4. So these two numbers work. And here we get x plus 2 squared equals negative 6. So there are no solutions because a square cannot be negative. And we have x plus 2 squared is equal to 4, which is x plus 2 equals to plus or minus 2. X is negative 2 plus or minus 2. x1 equals 0. x2 equals negative 4. So these are the two solutions. Hope that makes sense. Okay, so 6 and 7. Ooh, these I love these. Love these questions. They are usually quite hard. Not these ones in particular, but so these are called questions with parameters or equations with parameters. So this is an equation with a parameter. Equation with parameter. The K is the parameter. So how does that work? Well, let's do a Desmos graph. Let's say y is equal to x squared minus 4x minus 3 minus 1. Okay, so you have a parabola. A parabola which looks like this. Imagine we had, instead of 4, we had minus k. And we can add a slider, k. So basically, this is an equation of a parabola, but it has a parameter in. The parameter can take different values, and depending on that parameter, the parabola is different. Ooh. Ben, just a second. For my answer is for 6 and 7. So 6, K1 is 3 and 4. 3 and 4. And it is 3 and 4. It is correct. For question 6, it is correct. For question 7, 9 and 1. And no. Question 7 is incorrect. I mean, you found 2 solutions, but you haven't found the third solution. Okay, just Ben sent me a message with the answers, and yeah, almost correct. So well done, but there is a mistake in 7. No, I mean, 9 and 1 are roots, but there's another one which you've missed. So yes, so k is a parameter, and look what happens if I change this parameter. If I change k, the parabola changes, right? We can have 3 parameters. We can have a plus bx plus c. So now we have 3 parameters. And if we change a, it changes the parabola. If we change b, that changes the parabola. And if we change c, that changes the parabola as well. Okay, so it's quite interesting what happens. Note that the 4 doesn't change when I change a. 1 point remains it remains where it is, the 4. Well, it's 3.9 actually. And if I change b, it also doesn't change. This point stays where it is. It's quite fascinating. It always goes through 4 because that's the y-intercept, because that's determined by c. C is the y-intercept. So no matter what you do, the parabola would always go through this point. So it's quite interesting. So if you have a chance, play around with it. So these are parameters, right? So the parameters determine something about the parabola or about the equation. So this is called an equation with a parameter, where k is the parameter. It says for which values of k. So you need to understand that in this equation, b is equal to 3. So this is equation x squared. This is a quadratic equation plus bx plus c, where b is equals 0, b is 3, and c is this monster. So k squared minus 7k plus 12. It says one of the roots of the equation is equal to 0. So it's either x1 equals 0 or x2 equals 0. But we know that x1 times x2 from Veta's formula, we know it's equal to c. And we know that x1 plus x2 is equal to minus b, so minus b. But if x1 or x1 is 0, so this has to be 0. This has to equal to 0, because if x1 is 0, then this is 0. If x2 is 0, then this is 0. So c has to be 0. Therefore, k squared minus 7k plus 12 has to be 0. And this is a quadratic equation, which we can solve using Vetas again. So k1, k2 is 12. k1 plus k2 is negative 7. So k1 is minus 3. k2 is minus 4. Yes, I did here. Thank you. Well done. And that's it. So if k equals minus 1. So let's investigate a little bit deeper. Let's investigate what happens. So what actually happens? What happens if k equals minus 3? So the equation becomes x squared plus 3x plus minus 3 squared minus 7 times minus 3 plus 12 equals 0. So it's going to be x squared plus 3x plus 9. Whoa. Something went wrong. Something went terribly wrong. Plus 7. So plus 3 and plus 4. Sorry. Messed up. So it is plus 7. Sorry. What am I doing? So it's plus 3. And 4 is plus. It's plus, so 9 minus 21 plus 12 equals 0. Yes, thank you. Thank you, Dania. So x squared plus 3x plus 0, because 9 plus 12 minus 21 is 0. So plus 0 equals 0. So we have x squared plus 3x equals 0. And we can factorize it. X plus 3 equals 0. So x1 is 0 and x2 is equal to minus 3. Check. x1 multiplied by x2 is 0. The product of the roots is 0. What happens if k is plus 4? That's the other solution. If k is plus 4, what happens? Well, if k is plus 4, it's going to be x squared plus 3x plus 4 squared minus 7 times 4 plus 12 is 0. So it's going to be x squared plus 3x plus 16 plus 12 is 26. 16 plus 12 is 28 minus 7 times 4, 28, 0 plus 0 equals 0. And therefore, we have the same solution. Yes, we have the same x1 equals 0, x2 equals -3, and we have x1 multiplied by x2, which is 0. So I just want you to appreciate, if you haven't seen questions like this, what happens. So we need to find k for which this equation has the product of roots equal to 0. And that's, there are two solutions. So the answer would be, ooh, Ben, you figured it out. Yes, answer. K is equal to 3, and k is equal to 4. Yes, Ben, you're correct. Problem 7. For which values of a does the equation it shouldn't have this word. Does the equation have only one root? Right. So I'll explain to you why I removed that word, why I can't say quadratic equation. So basically, well, which values does the equation have only one root? Well, the equation has only one root if the discriminant is equal to 0. If the discriminant is 0, we have one real root. Okay. The discriminant is equal to b squared minus 4ac, which is a minus 3 squared minus 4 times a times c, which is 1. Sorry, I'm using a in two different, like, let's say it's q and this is q. 4ac, so it's q minus 3, 1 minus q times 1. Well, which values of q? Q minus 3, and that it has to equal to 0. So we have q minus 3 squared minus 4q is equal to 0. So open the brackets, q squared minus 6q plus 9 minus 4q is equal to 0. So it's q squared minus 10q plus 9 equals 0. Ooh, this is a special case. See, 1 minus 10 plus 9 equals 0. Therefore, q1 is equal to 1, and q2 is equal to special case. Q1 is 1, and q2 is c over a, which is 9 over 1, which is 9. So q1 is equal to 1, q2 is equal to 9. Now, we found the solution. Discriminant is b squared minus 4ac. That's the definition of a discriminant. So if you have a quadratic equation, ax squared plus bx plus c equals 0, a discriminant is b squared minus 4ac. And we know that if the discriminant is greater than 0, we have two roots. If the discriminant is equal to 0, we have one root. And if the discriminant is less than 0, we have 0 roots. Please read about this in the assignment. We have a page dedicated to this. Let me have a look. Here it is. In the equation 12, the quantity is known as the discriminant. It determines the number of roots of the equation. And here it is. Okay. So I hope that answers your question. Now, this is all beautiful, with one exception. And it's a very subtle catch. We say there's one root if the discriminant is 0. But only quadratic equations have a discriminant. We say a quadratic equation has one root if the discriminant is 0. But the equation has to be quadratic in the first place. What if the equation is not quadratic? Can somebody think of a value of q such that the equation is not quadratic? Yes, Theo, it is. Anyone else? Piranha, yes. Dania, yes. Well done. Interesting why everybody tends to send me direct messages, but it's kind of fun that way. But okay. This is only the if equation is quadratic. What if it isn't? What if it isn't? Well, if q is yes. If q is 0, if q is 0, then the equation is not quadratic. If q is 0, equation is not quadratic. Let's sketch it actually. X squared, qx squared. It's going to be qx squared minus q minus 3 squared plus 1, is it? Now, if I change q, something changes, as you can see. But something interesting happens when q is 0. Look, watch what happens. Q is equal to 0. Aha. If q is okay, I forgot x. So we have something changes, but if q becomes 0, look at that. It's a straight line. It's not a quadratic anymore. Because if q equals 0, the square term goes away, and therefore the equation becomes 0x squared minus 0 minus 3x plus 1 equals 0. So there's going to be 0. So plus 3x plus 1 equals 0. That x is equal to minus 1/3. It's one root. Therefore, q3 is equal to 0. So the answer, q1 is 1, Q2 is 9 and Q3 is 0, because that's a special case, because we have to consider all the possibilities. It's just a linear equation, and a linear equation has one root. Once again, it's a parameter which determines the equation. And you remember at the beginning of the question, I deleted the word quadratic equation because it's not always quadratic. Sometimes it is not quadratic. If Q is 0, it's not a quadratic equation. And this is a very subtle catch. And in the assignment, there is a question about this, and there is the same catch there. So there's nothing trickier than that. Okay, so what do we have left? Let's have a look. The quadratic function. Gonna go over the very last question or something similar. Very last question of the assignment, you mean? Question 18. Let me give you some hints here. Okay. Let's say that the height of a balloon can be found using h of t is equal to 700 minus 5t. And if I say, what is the initial height of the balloon? What is the initial height? Right. Well, you need to understand what this is. This is a function. This is a function of t. Basically, a function is a magic box. You put something in and you get something out. That's how a function works. Function. In this particular function, you give it a t and it gives you an h. So this is an h of t. You give it a time and it tells you what height it is. Okay? So you say, what's the height after 50 seconds? Okay, 50, you put it in. The function does something. So it does 700 minus 5 times 50. So it does 700 minus 250, which gives you 450. You say, what is the height at 100 seconds? And we'd say it calculates. So it says h of 50 is 450. H of 100, the height at 100 seconds, it's 100, so it's 200. Okay. And there are certain limits. For example, if you use 150, okay, 200 seconds. 200 seconds, you get h of 200, which gives us minus 300, which is not possible. Okay, you're not below the ground if it's a balloon. Yes, the recording will be posted on YouTube. And yes, so somebody asked, will the recording be posted? Yes, the recording will be posted. So it is a function. It tells you what is the initial height. Well, initial means when t is 0. When t is 0. So we need h of 0, which gives us 700 minus 0, so 700 meters. That's the initial height of the balloon. Then question is, how find the speed of the balloon? What's the speed of the balloon? What is the speed? Well, how would you do that? Well, I would say, well, when t is 0, h of 0 is 700. When t is 1, h of 1 is, well, 700 minus 5, so it's 695. So in 1 second, it went from 700 to 695. What's the speed? Well, the speed is 695 minus 700 divided by 1 second, which is minus 5 meters per second. That's it. That's how you find the speed. Okay. You want, so yes, I think I've given you too many hints on this one. Velocities, well, that's a good point. That would be velocity. Velocity, sorry. What is the velocity? Speed would be 5 meters a second. I'm very sorry. I shouldn't make these mistakes. It's embarrassing, but yes. Okay. Ben, of course not. That's why I'm not telling you. I'm not giving away the answer. But you do it in a very similar way. You just need to think what happens, and it does give you hints. Dania is asking, when will we know if we got accepted? So you submit assignment 1 on the 15th of October, hopefully before that. We mark it in 2 weeks, and roughly by the 1st of November, or at least the first week of November, you would know if you got accepted. Hope that makes sense. The official classes, start in same time. Once you get in, you get a tutor, and classes start. All right. Any more questions? I've run out of stuff to do today. How many people are participating this year in Year 10? Not too many, actually. We only have just over 200 applications for Year 10. So looks like more than a half is likely to get in. Would the class be the same length of the webinar? Yes, classes would be the same length as the webinar, 90 minutes. What about year 11? Year 11, we have fewer places for year 11. So yeah, we also have about 200 applications. So it looks like we have about 2.5 people per place for year 11. for these webinars. Yes, webinars will continue, will carry on every week, unless unless I'm very busy, then I'll let you know that I've cancelled. And hopefully we get some guest speakers. We have some guest lecturers that will do. Okay. What content will be covered after 15th of October during the webinars? It's assignment 2. Assignment 2 is trigonometry for maths, and for physics we are going to do electricity. So I'm going to do a bunch of questions on electricity and yeah. Assignment 2 will be posted on the 15th of October. maybe 16th or 17th. It's still not ready. We are working on it. But hopefully it will be ready by mid-October and published. It's going to be the same structure, maybe slightly fewer questions. I thought maybe 18 questions for the first assignment is too much, but then it's easier to, you get more time to do assignment 1. Assignment 2, you'll have 4 weeks to do assignment 1. So assignment 2, sorry. So I will try to make it slightly fewer questions. Okay. Ikshita, you're asking, is assignment 2 only if we get in? So assignment 2 will be available to everybody. But if you get in, you will also get a tutor who will mark your work and do another tutorial. Another tutorial with another tutor, right? And they will mark your work. You'll have conversations with them. Yeah, that's the difference. But you can still download the assignments and do the work at your own time, but it won't get marked. For each assignment after these, do we need to complete all questions? Okay, so we aim for a minimum of 50% completion. Once you get in, we expect you to do a minimum of 50%. Okay. Your first assignment will be marked regardless. The second assignment and third and fourth will only be marked if you do get in. If you get in, all of your assignments will be marked. We won't give you feedback, and yeah. How did you investigate the hydrogen bomb? Well, I'm not. I don't know the details, but it was. I mean, the university was open during in the beginning of the Cold War. It was actually founded in 1946, so right after the end of the Second World War, when the world decided to start a Cold War. And yeah, it was the beginning of the arms race. So they decided they needed something that can destroy the world, and they've designed it. Yeah, not too keen on weapons, so never did anything like that. If we don't get it, so if we complete the assignments after not getting in, we'll still do something we say is which we did. You can, yes. I mean, if you don't get in, but you still want to do the assignments, I mean, if a person can do the assignments, they'll get in. If you complete all the assignments, but if you don't get in but still complete all the assignments, by all means send them to us at the end of the year. Said, look, I've done all this amazing work. please could I get a letter of recognition, and we'll be happy to write you a letter then saying this amazing person have completed 20 exceptionally complicated assignments. They've done an amazing job, and we are very proud of them. Yes. But if somebody manages to do all of our assignments, it is unlikely that they won't get in. Like honestly, like if you can do our assignments, you are in. Okay, I have to say there's an exception. So because year 11, there's very limited spacing for year 11. So if you can do all of our assignments but don't get in because you're in year 11, you will get into year 12 because we will have more places in year 12. There are only 6 assignments for year 11. Well, I mean 12 because 6 physics, 6 maths. So it's, yes, Chloe, 20, I mean 10 physics, 10 maths. So not 20, 10 physics, 10 maths for year 10, and 6 physics, 6 maths for year 11. And for year 12, we have 10 assignments, 10 of each, 10 physics and math. And for year 13, also we have 6 and 6. If you're in the neighborhood concept you're getting after doing the assignments. So we are expecting, so if you're in year 11, what's the chance of getting in after you've done the assignments? We are expecting about 2.5 people per place for year 11. 20 times what I have on my desk now. 20 we want 10 maths and 10 physics assignments. So yes, it is a lot of work. We do say it is a lot of work. We do expect you to do on top, we do expect you to do about 5 hours of work on your own per week. So 4 to 5 hours per week. So you do need to, if you if you're trying to, I don't know, do many different things at the same time. So if some people try to do the quantum club and COMPOS at the same time, and we say, well, that's really difficult to do. It's yeah. So yes. So you have to prioritize. If you choose to do COMPOS, you might need to not do something else, right? Because if you have a hobby that takes up 10 hours a week, that will interfere with COMPOS, or COMPOS will interfere with that hobby, and you end up unhappy. So prioritize. Choose something you want to do. We don't want unhappy people on our course, but it is, as I said, a lot of work. So if you completed all the questions and didn't get into, just confirm there are about 30 places. There are, well, Daniel, we don't know. I can't say we have 30. We'll have to balance. We will need to see how many people submit the work. We mark it, we see how many we can accept. We can see if there are extra places we can provide. So it's from the perspective of the tutors, we have a lot of very good tutors this year, and we can accommodate many more students. The problem is or we might not have, we're sorting out the funding basically. If we have extra funding, we'll get more places. If you complete all the questions and didn't get into the year 11, does that mean all the other space will fill the people also completed everything? Yes. If you complete all the questions, then that, which is not very likely, hopefully. How many people have applied for year 11? Well, it's about 200 have applied, but out of the 200, about 40% actually do the work. So we're expecting to, out of 200, we're expecting 80 people to actually complete the work. You're going to get stuck, Chloe. Yeah, don't stress out. Like, honestly, if you can take the easy route, you can take the follow along route where you just do it in your own time and you don't have to submit it every week. But and then decide whether you want to do it and then apply for year 12 or year 11. So yeah. When we get a certificate or a letter, you do get a letter at the end of the course. Yes, a letter from Oxford University saying that you have completed such and such assignments, and yes. So yes, if you are unsure that you can spend if you're unsure that you can spend 4 to 5 hours a week every week doing physics and maths for COMPOS, you might want to just do the assignments in your own time and then join in year 12. So just to see. But of course we would like to see you on your course, but the one thing that we don't want is you stressed out, because you have you're doing COMPOS, you're doing tennis, you're doing football, you're doing golf, and then you are absolutely exhausted. Here applying the year. Look, if you we have transfer students. If you do well in year 11, you automatically transfer to year 12. And by do well, I mean you do all the work, you submit it, then you get an automatic place in year 12. If you don't, if you don't do year 11, if you choose to just do it in your own time, you just reapply in year 12, and hopefully we have many more places in year 12 than in year 11. Okay. So yes, so I hope you enjoyed today. I hope I managed to answer your questions. Then I'll see you next week, and enjoy doing the assignments. See you everyone.